Hey guys, okay, so we've already covered that we know Earth is changing. Now we're talking about how do we know how old the Earth is? There's a couple main ways that scientists discover this. Yes, I am looking at the textbook exact assignment you're doing today. And one of the big ones is absolute dating, and the other one is relative dating. So for absolute and relative dating, it's just a comparison for how old things are. Relative dating is your relative age. So it's relative to other things. Like you could say, I am the youngest one in the family, or I'm the oldest one in the family. Absolute dating is your absolute age. So like I am 13 years, 2 days, and 12 hours old. That's your absolute age. Now, do remember when we're dealing with millions of years, you could have plus and minus a couple million years, and that doesn't change a whole lot in the world of geological age. So if I asked you for your relative age, you'd be like, oh, I am the oldest in my family, or I am the youngest in my family. And this is because of the law of superpositioning. Law of superpositioning. Okay, remind me not to try to write next time. So the law of superposition has to do with the position of the rocks. Remember, we talked about laws and theories before, and so we know that it's something that's backed up by lots and lots of scientists. In the law of superpositioning, old stuff is on the bottom, young stuff is on the top. And it makes sense. If I was building a tower of rocks, I would have had to put this dark brown one down before I put this one down up here. So you make a nice tower with the law of superpositioning. But this only works if there's no giant earthquake. And the whole thing falls over on its side. Because once it's on its side, this one could now be on the bottom. And if we're following the law of superpositioning, that would mean that, oh no, we now think this is older than this one. So it is worth keeping in mind, if we're following relative dating, we have to use the law of superpositioning, which said oldest stuff goes on the bottom, youngest is on top. It's the same way like you could tell how old stuff in your trash can is. The candy wrapper at the bottom of the trash can is going to be older than the cheese wrapper that you just dropped in a few seconds ago. Okay, so looking at that, there are some videos in your notebook in here and some pictures that'll help make your life a little bit more easy when you study them. The next thing we're going to be looking at is going to be looking at the fossils. We started talking at the fossils already. This is going to make our geological time scale. Remember, geological involving geology or rocks. So the geological time scale is a little bit different than our common day. So instead of having years and months and days, we're going to have eons, eras, periods, and epochs. It's also different than normal measurements because, like for us, we know that a year is always a set amount of days. And a month is almost always the same set amount of days. And a week is always the same amount of days. And an hour is always the same amount of minutes. And a second is always the same amount of milliseconds, and so on and so on. But that's not how the geological time scale works. For this one, we can see here that the Archean eon, up here underneath the Pinterest picture, is only 4 eras long, while the Phanerozoic eon is 3 really big eras long. And once we look into that, we can see that the Cenozoic era is 2 periods, while the Mesozoic era is 3 periods. So these dates and these times get set up based on what happens. The more stuff that happens, the more divisions you have. If you have very few divisions, then not as much stuff is going down. If you've got tons and tons divisions, then lots more stuff happen. So keep in mind that even though there's different time frames, we can see that this one had way more stuff happening.